Hey, so thanks for coming out. Appreciate it. Conceptually, let's go to the beach. Let's see if this works. All right, so if you go to the beach, you'll find scenes that look like this. You'll see lots of cool sea creatures sticking to the surfaces, sticking to each other. And what these animals are doing is they're creating a really interesting class of adhesives that are unlike anything that we have access to that are man-made. And so what we're doing in our lab is half of our lab is actually trying to characterize and figure out what these materials are. The other half is we're actually developing synthetic mimics. And one of the things we're always after is new materials with high strength, but also with unique properties we've not had access to previously from our current adhesive material. And so this is my last slide. We're already on the last slide. Basically, what we're doing is if you think about properties you want to incorporate into new materials, we're adapting adhesive chemistry that way. There's this one system, this is sort of our parent system we spent the most time with. In dry bonding at the moment, it's stronger than super glue and Gorilla Glue and Elmer's glue and all that stuff. And it seems like at the moment, it's the strongest available adhesive for working on completely underwater or wet substrates, so it's kind of fun. In this case, what we're doing is we're taking this adhesion chemistry that we get from the sea creatures, and we're combining it with, in this case, it's polylactic acid, which you can get from corn. So this is our surf and turf polymer that we have here. So it's bio-based, it's degradable, it's probably non-toxic. We're working on that now. We also have, there's actually a significant need for making new materials that are new adhesive materials that have tunable flexibility. I won't go into the details at the moment, but basically, if you can tailor the amount of one of these components that you put in the polymer versus another, you can make something that's really stiff, really flexible, or anything in between, and this can actually help mitigate the mechanical stresses in the bond, and this is something that's useful there. And then we also have some, we're trying to make adhesives using really cheap components, sometimes even from food. We can take really bulk scale proteins, we can turn them into adhesives, and then in this case, this is 2 pieces of wood that we bonded together, and this is a pin put through there to break it apart. You can see that the adhesive joint stayed intact while the wood actually split when we were trying to test the bonds. Right? So basically, we're looking at nature. We've got lots of cool ideas from what the sea creatures do, and then we're developing many different classes of materials with different properties that we're after. Thanks.